Hi, my name is Kent Fellows, and I'll be presenting a podcast on Lewis dot structures today. This is Gilbert N. Lewis. He is known for a lot of things in chemistry, namely acids and bases, photochemical experiments, and like I said, Lewis dot structures. So those are named after him. What it is it's a diagram that shows where the electrons in a molecule are distributed, and it contains lines which show the bonds between the different atoms, and dots which show the lone pairs of electrons around them. And each atom can only contain 8 electrons, whereas hydrogens can only contain 2 electrons. So that's just something to keep in mind as we work these later on. So here are the steps to Lewis dot structures. The first thing is you have to sum up all the valence electrons of the atoms. So we've got CCl4 here. So the C, and then you have 4 Cls. And the C has 4 valence electrons as found on the periodic table, and all of the Cls have 7 electrons. So you just add all of these up, and it equals 32 total electrons. So we'll have to remember that as we continue. So we had 32 total. Use a pair of electrons to form a bond between each atom. Note that there are 4 CCl bonds present. So what you do is you start with the C and you draw those bonds around it. So you got a Cl, got a Cl, Cl, and one more Cl. So this right here is the first part of the structure. And we'll continue. Next, what we have to do is arrange remaining electrons to satisfy the octet and duet rules. So each bond takes up 2 electrons, so you subtract those from the valence electron total that we added up earlier. So we've got the CCl bonds, and then we start drawing dots like that around it so that each atom contains 8 electrons. Lines here, these all contain 2 electrons, and they're shared between each atom. So we continue drawing the dots, and now we've got 8 on each atom. The C right here in the middle has each of these lines, which are all 2, so that's got 8, and then the Cls each have 8 as well. So the lines kind of add up to that as well. Alright, so that's pretty much the basics. Now we've got one like CO2. So CO2, when you start and you try to do the same thing that we just did, we've got those 2 single bonds, and first you'll add up the valence electrons like I said, and you'll get 16 total electrons that you have to distribute around here. So we've got 4 right here, 2 and 2, so that's 4, and then we start drawing dots around the O's, and we realize that we only have 12 electrons distributed around, so we've got all 16 electrons on here, but the C doesn't have its octet rule satisfied. So the way that we treat that is we take away these electrons right here on the O, and we take away these electrons here on the O, and we add a bond right here. So they're both sharing those electrons. And, that right there has 8, that right there has 8, and that right there has 8. So each one can only hold 8, and whenever we run into something like that, we take away the lone pair electrons and we just add a bond to make sure they all have 8 electrons to satisfy the octet rule. So here's just a recap. You can pause it and look it over, and thank you for watching.